Welcome to the Salmon Runs YouTube. Enjoy the video.
You start by preparing your environment and understanding the minimal math you need. Install a quantum SDK like Qiskit or Cirq and confirm Python 3, 8 or newer runs. Once done, register for a provider account, copy your API key, and set it in your local config so the hardware can be accessed. Make sure to run a simple SDK example on a simulator to verify the install. This proves your toolchain and credentials work before moving to real devices. You now construct and validate the quantum experiment itself. Start with a 1-3 qubit circuit using X, H, C0 gates to express the algorithmic idea. Write unit tests that assert expected state vectors on a simulator. Once done, transpile the circuit for your target backend to map qubits and reduce gate depth. Make sure to include simple error mitigation, like measurement calibration and readout correction, so simulated fidelity estimates translate to realistic hardware expectations before queuing a real job. You finish by executing on the quantum device and interpreting outcomes. Submit the transpiled job, watch queue status and calibration data, and choose a runtime when readout errors are low. Once results arrive, compute measurement statistics, plot distributions, and compare against simulator predictions to isolate quantum advantage or hardware noise. If outcomes deviate, retranspile with different qubit mappings, increase shot count, or apply stronger mitigation. This troubleshooting step often restores expected behavior without changing algorithm logic.
Thanks for watching. Consider subscribing if we helped you.